Hi, welcome to another mini lecture. The topic today is using a trigonometric ratio to find a side length in a right triangle. Well, now we are gradually getting into interesting parts of trigonometry, which is applications in geometry. So, suppose you are on Lamar campus and you are curious about how tall grade library is. So there's a library here, and suppose I give you a project, find out how tall it is. And let's say you're not allowed to go climb all the way up here and so I don't know, drop a rope or something and try to find the height like that. How can you actually find the height from the parking lot in front of the building? Another question, suppose there is a mountain and we want to find the height of this mountain. How can we do that, given that we would not be practical to go up there and drill a hole all the way down here or something of that nature? What's a practical way of measuring the height of a mountain from perspective of a course in trigonometry? And the next question, how did the ancients find the radius of Earth? People from many centuries ago calculated the radius of Earth in various different ways by using trigonometry. These are all very nice projects in increasing degree of difficulty. You can take on any of them. So let's go ahead and learn about this. So let's again go ahead and do a quick review of trigonometric ratios we have. So suppose I have an angle theta here, and this is A and B, and this is C. And then we know that sine of theta, so we are upgrading from the regular letters to Greek letters. So you see a few of these things, you want to get used to them. And this one's called theta. So sine is a ratio of B to C, of course. And cosine is a ratio of, well, what was that? A to C. And how about tangent? Tangent is a ratio of B to A. Well, all the problems you had so far, these sides were given and you were calculating these trig ratios. Now, the angles are given, this angle theta is given, and then we want to find some of these lengths. At least one length is given, and then we are going to find some missing quantity. This is the beginning of what they call solving a right triangle. Some information about the triangle is given and you want to find others. So each triangle has three sides, has three angles. So we are walking toward the objective of these six quantities. If they give some of them to me and they ask me for the rest of them, how would I do that? So that's a general plan that we are after. So here's the first one. Solve for x in the triangle, round your answer to the nearest tenth. So expectation is that you're going to use your the calculator that's on the screen. So in all of these problems you see some angle is given, some length is given, and then there is a quantity that you want to find. Well, the best thing to do is to write the relationship between these three using the three basic trig functions, whichever of them that works for you. So I have these three. So I ask myself, I have an angle, and the other item that's given is the opposite, and what I'm looking for is the adjacent. So these are the three cast of characters in my problem. What trig relationship connects these three things to each other? So I ask, well, sine of, not the sine, what is it that connects them? It is tangent, of course. Tangent of an angle, like in this case 34 degrees, is equal to ratio of opposite divided by adjacent. Is that right? Tangent is ratio of opposite to adjacent. of these three quantities, we know two of them, that is the side 17 and the angle 34 and its tangent. We want to find x. So how do we do that? Multiply by x, so it becomes x tangent of 34 degrees is equal to 17, and so x is equal to 17 divided by tangent of 34. Here remember, issue on a calculator, set your calculator into degrees if the angle that's given to you is in degrees. If it was given to you in radians, then you do accordingly. You set the calculator in radians first, and then you go about finding this. So on the calculator you enter this and then you are to get the answer to certain accuracy. So nearest tenth, you round it to the nearest tenth. Just so that we get the most bang for the buck here, let's suppose some other question was given to us. How about the y? Well, what is the relationship between this three green items now, 34, y, and 17? What connects them? So of course now we say sine of 34 is a ratio of the opposite to hypotenuse. Is that right? Sine is a ratio of opposite to hypotenuse. So let's see if we can learn something to do this quick. If I have an entry here in the numerator and entry here in the denominator, what we achieved here, notice what happened here. I had 34, tangent of 34, now I have the tangent of 34 here. I had x down here and now xi up there. So if you have two fractions, you can exchange the numerator of one with the denominator of the other one, and that would be your quick way of solving it. Or if you want to just go ordinary way, y times sine of 34 is equal to 17, and therefore y is equal to 17 over sine of 34. Is that right? So you can exchange these two, numerator of one with the denominator of the other one, and then so this was a side problem with it, just so that we get the most benefit out of this. So of course this angle is always 90 degrees, so that's nothing to work on. And how about this one? This is 34, and that has to be complement of that, so that's going to be 56 degrees because they have to add up to 90. So the idea is that there are 6 pieces to a triangle, 3 angles, 3 sides, and when some of them are given, you want to find the other ones, and then we're going to have a longer story about this thing coming up later on, but that's the general perspective that you have. Here is a similar problem, well, almost like the one we just did. So I have these three, so I have x and 13 and 35, and what trig function connects these things to each other? Okay, so with respect to this, that would become the opposite of that. So I'll have sine of 53 is equal to x over 13. Is that right? So x, in this case, I multiply by 13, so I have 13 times sine of 53, and that is, so x is 13 times sine of 53 degrees. Again, you set your calculator into degrees. Nearby problem, of course, is what is y? Well, in this case you consider these three, and then you can say well, cosine of 53 is y divided by 13, therefore y is going to be, so you multiply by 13, becomes cosine of 53, and of course again this is of trivial, this is 90 degrees. This one 53, what is left? 37 is left here. So all the missing quantities, we found them. Well, the problem just asks for one item. What else? Let's see. Just like what we have done several times now, x 36 and 6. So we talk it out like this. What relation connects an angle to its adjacent and the hypotenuse? What relationship connects an angle to the adjacent and the hypotenuse? Well, of course, that is cosine. Cosine of 36 is x over 6. In this case, you just cross multiply. X becomes 6 cosine of 36. This is a kind of relationship that you want to be automatic about it. That is, hypotenuse times cosine gives us the adjacent. Hypotenuse times the cosine gives the adjacent of the angle. What if the question was, what is y? Well, similar to this one, y becomes hypotenuse times the sine of 36. I leave that for you to find out. So here the answer to the problem was 6 cosine of 36 degrees. Looks like all these examples, the angles are given in degrees. So this one we have hypotenuse missing. So we have hypotenuse missing here, angle is given, and the adjacent. Well, again, the relationship that connects these three is what? How do I connect adjacent to the hypotenuse? Of course, I use cosine. So I say cosine of 22 degrees is 11, which is the adjacent divided by hypotenuse. So of course x is going to be, this is going to be one of those problems we exchange the location or multiply and divide. Cosine of 22, just for practice sake, if this was given as if we were asking to find y, we would have said what, given these three. Okay, so you always work with what is given and what you're trying to find. There are also alternate ways of doing this thing. So we say what relationship connects an angle to its adjacent and opposite. To adjacent and opposite, of course, that's tangent. So tangent of 22 would have been opposite, which is y divided by adjacent. In this case, I just multiply, so my y becomes 11 times tangent of 22. So all of these cases, you have to do a little bit of work on the calculator to figure out the missing quantity. Okay, so of course this is also trivial, that this is going to be 68 degrees, so that they add up to 90, and this is 90, and then we have all pieces figured out. So we used somehow all these examples. Well, the first one we had an example of tangent. So once again, you want to write these relationships and write a relationship that connects a trig function, one of these basic trig functions, to the two items that are given and the side that you're looking for. So you have to find a function that connects those two. Interesting projects to do. Well, how do we apply this thing to figure out length of items around us? Tall objects, trees, buildings, mountains, Earth itself. Gradually problem becomes more and more interesting. Okay, hopefully one of you guys takes on one of these projects and you let me know how you found out the radius of the planet you live on. Until next time, good luck and bless.